Okay, welcome back to algebraic transformations. We're building our skills to be able to do some algebraic artwork, to be able to take some functions and create some artwork. We're going to talk about parent graphs. This parent graph that we're talking about today is the one we're starting with. It looks something like this. You can see that. Let me get a little closer. It is that y1 function is x squared. Well, that's the parent graph of the quadratic. Where a is 1 and b is 0 and c is 0. This is what it looks like graphed on an xy axis, vertical and horizontal, where the origin is at 0, 0. That would be the vertex as well of it opening up and looking like that. That's the parent graph. That's Papa. That's what y equal, or a function f of x equals x squared looks like. So that's that. And let's learn how we can mess with him. You want to mess him up? Well, let's see if we can do some things. We're going to look at first how to vertically do some things. So keep in your notes, we're looking at vertical things. We're going to look at how to do things up and down with the parent graph. So looking at x squared. Again, this is what he looks like. This is Papa. This is Dad. This is Mama graph. This is the parent graph. We're going to stay in this x squared function for a while, and so everything that we do won't change the family that it's in. It'll always look like one of these. Now it may open up or down, but it will look like this Papa. So we're going to look and learn first how to vertical shift it. So let's see what we can do with that. Now, vertically shifting it would mean moving up and down. We're going to look at how to mess with the algebra. What can we do with x squared there being the algebra? What could we do with that function to make it go up or down? Well, we can do things like we can add things to it, or we can subtract things from it, or we can multiply, or we can do negative multiplication, stuff like that to it algebraically. Well, what do you think? What would move it up or down? What do you think? Would adding it or subtracting? Well, let's just guess. And so we don't really know. Let's just go to that function and let's just I don't know, add something to it. Let's see what adding does to the function itself, to the Papa. So again, let's see what we did algebraically. X squared plus 2. Let's just see what that does. Again, we don't have to take time to wonder, or we just ask questions, we investigate, we connect with what we already know, we discuss with each other, and then we reflect on what we did. So let's discuss. We've asked, how do we take algebra that looks like a U that opens up, and what do we do with that? How do we get it to move up and shift up? Well, let's just see. Did it look like it shifted up? Did we take it? Yeah. Originally, it was going through a 0, 0. As a matter of fact, we can play with our graphing calculator to get the look of what Papa looked like originally, and then what it looked like that second time. So again, you see that it's just been shifted in an up direction. The origin's up, and every other point that was on that original one that went through the origin, it's moved and shifted up. Well, that again is what we want to learn. Again, you can kind of see some artwork happening here, where you've got two curves put together that make you can start seeing artwork start showing up. So again, let's compare those two algebras. Let's see what that happened. Y2, excuse my orientation malfunction and not knowing how to move to get it to look right. You see that Y1 is the second function, I think, plus 2. And then the x squared is the parent graph, and so that's what we looked at originally. Well, let's see. We're going to move it up. How would you move it down? Yeah, okay, maybe adding a negative or subtracting. We've learned in algebra that subtracting a positive 2, which is what you see there, is the same thing as adding a negative. You can think of it in both different directions, different ways, but it creates the same thing. And so that's, if adding 2 moved it up to the parent, then maybe subtracting 2 would move it down. And so again, I hit the graph key, and we see, oh yeah, you're right, that does move it down. And so you see again some artwork creating. I'll show you how to do this now, or at a different time. Gosh, if I can remember. I wanted to get rid of the axis, so I think that's in format. Yeah, if I turn that up and down axis off and then hit the graph again, you can just see the artwork of the parent graphs themselves start taking shape. and you see the artwork taking form, right? Well, that's moving it up and down, vertically, up and down, vertical stuff, shifting it, we call it, scooting it. I think the algebra books call it translating. And again, that's a T word that I don't really use much and think about, but that's how you can shift. So that is how to vertically shift algebra functions up and down. Now that'll work regardless of what the parent graph is. If we have a different parent graph, which, let me get the axis back up there. If this was the parent graph that we're talking about, let me just type in another one, or not another one, but a different way of typing the same thing. If this was the parent graph that you see on the Y2, it's not x to the second power, but x to the third. Again, that's a parent graph. That's what Papa's going to look like. Let's look and see how that graphs out. See, so you see in that first quadrant that you're looking at, that you have it's up in the first quadrant, it's also down in the third quadrant, but it goes through the origin at 0, 0. So it's sort of like an S, if you want to look at it, sort of like some of my students have called it the Stevenson S, the cubic function, we call it, the third degree polynomial. Well, that's the parent graph. Well, let's see what happens. Can we move it up the same way? Can we take that x to the third power and move it up? I'm going to move it up 3 units, and let's see what happens. Here's Papa. Oh, and there it is, moved. It's just scooted up, just like if somebody took it and took every point and just shoved that thing up. Again, if we wanted to go x to the third power and then move it down, we could do the same thing. And I'm going to try to get it up here so you see as it's graphing what it kind of looks like. There comes that third one, just shifted down. Now look at that artwork. Okay, so again, I'm going to get rid of that axis, so that all you see is the function itself. Graph it again. And you see that artwork start taking shape, like a flame or something in there. Okay, so you can create art, you can create geometry, looking pretty nice, with algebra as it graphs. So René Descartes was a French mathematician back in hundreds of years ago that first was given credit for the first time giving connection between algebra and geometry. The algebra to the geometry. And so what I want us to do, again, that's one thing. We've talked about vertical and we've talked about shifting. So we've learned that today. We can come back tomorrow, and I want to keep these videos somewhat short. We can come back and learn how to vertically shrink or stretch or compress. Those are the two words I'm going to use, vertical stretching and vertical compressing. We're going to look at how we can do that. So tomorrow, again, we'll play with some different parent graphs and different functions, but that's how you do it. Hey, congratulations. You are on your way to making algebraic artwork. Thank you.